Hello everyone, you are watching Learn with Lovejeet, and in this video I will be discussing strings in C language. What is basically a string? A string is a sequence of characters. Like here, I have declared an array named text, the type is character, and I have initialized this array of character type with 5 elements A, B, C, D, and this is my null character. Okay. This is same as declaring a array of integer type. Okay, here I have declared a array named A of integer type and it holds 5 elements of integer type. Now in case of string, the data type of elements is char. Okay, so there are 4 elements and this null character basically is useful for the compiler. The compiler locates the end of one string using this null character. Okay, so what is basically a string? A string is a sequence of characters. Now string constant is basically a 1D array of characters terminated by a null character. Here text is basically my 1D array, that is one dimensional array, and it is terminated by a null character. The null character is basically helps the compiler to locate the end of the string. That is, first it will read A, B, C, D, and when it reads this null character, it automatically will be able to think that it has reached the end of the string. Okay, so here now this inside this printf statement I have used this modulus s format specifier. Basically this is the format specifier to print a string. Okay, now this text, what this text will give me, as same I have discussed in array, that the name of the array will give me the address. So this text, writing text here gives the base address of this array. Okay, now when we use this modulus s as format specifier, what we have to give, we have to give the address of the array as its argument. Okay, so here the string will be printed. Let's see, let's try to print here. See, A, B, C, D. So because of this printf statement, I am able to print this whole string in one go. Okay, now on line 16 I have declared a variable of integer type I. On line 18, for loop state body begins, I initialized to 0, the test condition is I less than 4, then I plus plus. Okay, then one by one I am printing the characters. Basically text I, text, this is basically equivalent to pointer text plus I. Here I is 0, so text plus 0, that is base address plus 0. Base address, the value at base address is A, so A will be printed. Modulus C for printing the character, modulus D for integer, modulus D for character. So A will be printed, then I equal to 1, B will be printed, then I equal to 2, C will be printed, I equal to 3, D will be printed. Okay, so A, B, C, D. So simple. This was our string. Now next, from the next example. Also, here there are two ways to declare a string. Either I can give these elements separated by this comma operator, okay, inside curly braces, or I can declare a string like this, A, B, C, D. Okay, simple. Inside this double quotes I have written A, B, C, D, and this modulus, sorry, this null character will be present by default at this, okay, at the end of this. So here A, B, C, D, A, B, C, D, same. Okay, this is a shortcut basically to declare a string and initialize it. Now next, here I have declared a string named text of character type, okay, initialized with ABCD. Now here on line 7 I have declared a variable named I, initialized with 0. On line 9 I have declared a pointer ptr of type char star, that is ptr will be pointing to some variable, okay, some named memory location that will hold character type elements. Okay, good. Now on line 10, ptr is given the address or is assigned the address of text. So now base address of text, this array of string, is stored in ptr. Okay, now line 12, while text I print. Here, the ASCII value of this null character is 0. Okay, so ASCII value of is 0. So ASCII value of A is 97. It is non-zero. So this will execute because I've already told that while loops and all other statements, okay, decision statements execute the next statement when the test condition becomes true. Okay, so a text I, first time text I will give me A because base address ptr is storing. Okay, I've in this here for the statements from line 13 to 17 we are simply printing the values of text. We are not using the ptr. Okay, so text I, that is text 0, will give me A. Okay, so A, ASCII value of A is 97, so it is non-zero, so A will be printed here. Okay, then I plus plus, I becomes 1, then text 1 is B, so B will be printed here. I equal to 2, okay, text 2 is C, will be printed. I equal to 3, text 3 is D, okay, D will be printed. Now I equal to 4, at I equal to 4, what is present? Null character. Okay, I've already told that by default when we declare a string like this, at the end of the string something like a null character, something like this is present, and ASCII value of this is 0. So when I test text 4, 0, this is text 0, 1, 2, 3, 4. So at text 0 null character is present and the value of this null character ASCII value is equal to 0. So 0, this will give me 0, so the control will come out of this loop. So what is printed inside this while loop? A, B, C, D. Okay, now this is basically printing a new line. Okay, now inside this while loop, pointer ptr is tested against whether it is equal to null character or not. Okay, first time what will ptr give me? Pointer ptr will give me. Ptr basically stores the base address of this, so base address is equal to base address of A is equal to address of element A. So pointer ptr, but it will give me, A. So A is equal to null character, no, so A will be printed. Now ptr plus plus, that is it will point to the address of element B. Okay, ptr basically simply when I have written this line, okay, ptr simply points to the address of this. Okay, now this is character type element. Okay, so when I add +1 to this will point to the ptr will point to the next element. Okay, so now on incrementing, ptr will point to B, so B will be printed, then ptr will point to C, will be printed, then D equal to null character, no, so D will be printed. Now ptr is incremented again. Now ptr will point to the null character. Now null character is equal to null character, yes. Okay, so this will give me false, so it will come out of the slope. So here ABCD, then ABCD, first ABCD because of this, then second ABCD because of this. Okay, first ABCD, this one ABCD because of this, and this ABCD because of this. Now next, here I have explained here some of the library functions related to string. Now declarations of these functions, like I have the function string length, string comparison, string copy, and string concatenation. The declaration of these functions are in string.h, that is string header file. So I have to include this header file while I'm using these functions to tell the compiler about the type and the type of the function, its return type, and the parameters that it takes. Okay, now here on line 6 I have declared a string of type char. Okay, array of type char named text1 initialized with abcde, text2 edcbe. Okay, text3 simple. Text3, I have told the compiler that there exists a string of size 6, okay, named text3. Line 12, length and comp integer type variables, uninitialized. Now on line 6, I've used this function string length strlen, and inside this round brackets text1. So text1 is given as the argument to this string length. So what it will output? It will output the length of this string. So what is the length? it will be equal to the number of elements. So the number of elements is A, B, C, D, E. At the end of the string, null character is also present, but it is ignored. Okay, simply I am printing the characters before this null character. Okay, so it will give me A, B, C, D. So string length is equal to 5. Length is equal to 5, so 5 will be printed. Let's see what is printed here. So 5 is printed. 6. Okay, space also have ASCII value. Only the null character has a 0. Okay, other values are 1. Other values are greater than 0. Okay, so this space is also counted as one character, and when I try to execute string length on text1, so it is also counted. So the number of elements is now 6. Okay, now next comparison, string comp text1 text2. Basically I am using this string cmp function to compare these two strings, text1 and text2. I'm trying to find out whether these are same or not. Okay, first I will give both the values as 0. Okay, so now string in string comp function, what is done, basically characters in the strings are compared string by character by character. Okay, now A is equal to A, then move to the next vector. B is equal to B, yes, move to the next vector. C equal to C, yes. D equal to D, E equal to E. So what will be returned? 0. Okay, 0 means the strings are equal. Okay, now EDCBE. Okay, now I am comparing again text1 and text2. Now A is equal to E, no. Now if the first character, the ASCII value of the first character is less than equal to the ASCII value of the first character of another string, and these are non-matching characters. Okay, the values are not equal, so what will be printed? -1, because A, okay, the strings are compared character by character. Okay, the ASCII values are compared. Okay, if the ASCII value is equal, then move to the next. Otherwise, return -1 if the character in the first string, that is first string is basically my text1. Character in the first string is less than the ASCII value of the character in the first string is less than the ASCII value of the character in the second string. The okay, character in first string is A, character in second string is E. Okay, ASCII value of A is less than E, so what this function will return? It will return -1. So here -1. So here -1 is written. Okay, now I am again comparing this text2 and text1. However, I have changed the order. So now my first string is text2 and text1. Okay, now E is compared with A, matching, not matching. Now ASCII value of A is greater than ASCII value of E is greater than ASCII value of A. Okay, and E is my character of the first string. Now ASCII value of it is greater than A, so what it will return? 1. Okay, so when the values match, 0 will be returned. In case the values don't match, the ASCII value don't match, non-zero value will be returned. And if the character of the first string is less than ASCII value of the character of the first string is less than the ASCII value of the second string, okay, then -1 will be returned. Otherwise, if the ASCII value of the first character is greater than ASCII value of the first character of another string, then 1 will be returned. Okay, so first A was less than E, so -1 was returned. Now E is greater than A, so 1 is returned. Okay, now next. So this was string length, string compare. Now third function, string copy. String copy. I am giving it as arguments as text3 and text2. Basically, the content of text2 will be copied into text3. Now the string length of text2 is 5. Okay, so when I'm copying this content of text2 into text3, I have to make sure that the size of text3 is greater than or equal to the size of this. Okay, only then the string will be copied legally into this. Okay, so now I have copied text2 into text3. Now I'm printing, time to print text3. So what will be printed? EDCBE. So EDCBE, the string has been copied character by character from text2 to text3. Okay, now next, string cat. This is basically a concatenation. First text1, then text2. So take text1. Text1 is A, B, C, D, E. Okay, leave the null character. and then append this edcbe after this text1. Okay, and the null character of text2 will remain at the end. So abcde edcbe, then null character is present at the end. Okay, so this was string concatenation function. Now there is another function that is not declared in the string.h file, but it is general. Like I have used it to print the size taken by integer data type and character data type in my previous videos. So I will be using it here also. So like here, sizeof operator. Okay. So inside this sizeof text1. Okay. So length gave me 5. Now let's see what sizeof will give me. It will give me 6. So sizeof will count the null character also. Okay. It will also count it in the size while computing the size. Okay. So this was all about strings, and in my next video I will be discussing strings along with pointers.